Bismillahirrahmanirrahim. Before we start, can you mute your microphone? Right. So today we're going to learn a new topic in STA 104, Introduction to Statistics, chapter number 3, which is Numerical Descriptive Measure. So under Numerical Descriptive Measure, we're going to learn measure of central tendency and measure of dispersion. Of course, measure of position as well. So we start with, I'm going to introduce to you measure of central tendency. Right, so measure of central tendency is a value used to represent a group of data distribution. Right, for example, if you want to, you have data about age of the children in playground, so we can have one value to represent the age of the children, such as mean, mode, or median of the age. So a measure of central tendency can be mean of the value of data, middle value of data, which is mode, median, and most frequent value of the data, which is mode. And the popular measure of central tendency are arithmetic mean, or simply mean, median, and mode. So others measure also we will discuss in next topic, which is quartile, interquartile range, standard deviation, and variance. So a group of data can be either ungrouped or group data. So we're going to discuss two kind of data, is ungrouped data and group data. Right. So let me start with arithmetic mean. So arithmetic mean is a commonly known as average of the data value. Right. It is sum of all values data divided by the number of data observation. So the mean can be calculated by using ungrouped data and group data as well. Right. So this is a formula for ungrouped data, mean calculation of mean for ungrouped data. X bar is our symbol for sample mean. X bar is a symbol for sample. So this is the formula for calculating sample mean. Summation of X bar equal to summation of Xi, where I is from 1 until n, and divide by n. So I is number observation, Xi is the data value for each observation, n is number observation. So this formula is for group data. Right. So for group data, the mean can be calculated by using this formula. Right. So the formula for group data is X bar equal to summation of fx, f is the frequency, and x is our data value, divided by summation of f, which is a total number of frequency. Right? So now look at example number 15. So example number 15, to calculate arithmetic mean for the following data, by looking at this data is not in a frequency table, right? So this is a ungrouped data, right? So to calculate this mean for ungrouped data, we're going to use X bar equal to summation of X divided by n, where X, this is X number 1, this is X number 2, X number 3, and so on, right? So to calculate mean for ungrouped data, 5 plus 3 plus 8 plus 12 plus 18 plus 20 plus 24 and 25. So divide by how many observations are there? So we have 1, 2, 3, 4, 5, 6, 7, 8. So divide by 8. So this one should be equal to berapa? So what is the value here? The total is 115 divided by 8. And this one should be equal to 14.375. So this is the value for mean on group data, right? Are you okay? So, right. So now look at example number 16. Right, calculate mean age for the following data. So we have this is a group data, right? This is a group data because the data is presented in a frequency table, right? By looking at this one, we have age and number of students. So this is your frequency and this is your age, value of age lah. 18, 19, 20, until 22, right? To calculate mean for this data, we're going to use x bar equal to summation of fx divided by summation of f. We're going to use a formula from a group data. Right? So now, so we have the value of x and we also have value of f. So the formula asks us to find summation of fx. So we need to create another column, which is fx, right? Fx. So we need to multiply f and x. So this one going to be 180, and this one should be 532, 640, 315, 110. Right. To be 1777, right? So then this is the value of summation of fx. So once you have the value, plug in into the formula. So summation x bar should be equal to 1777 divided by 90. So this one should be equal to 19.74. So this is the value of a mean age of the student, right? Are you okay? Right.
Yes, sir.
So this is for when you have a frequency table without a class size. So if you have a frequency table with a class size, such as in example number 17, right? So this is a frequency table with a class size 700 to 799. This is the frequency of the, number of employee. So if we want to find the mean for monthly income from 74 employees, so we're going to use the formula of group data, summation of fx by summation of f. Right. Right. So we continue. So this one, so to find x, we don't have x here, right? So we need to find the value of x. The value of x for this table should be the midpoint of the class. So this is x, midpoint. You need to find the midpoint for each class, right? So 800 plus 899 divided by 2, it should be 849.5 and so on. 949.5, 1049.5, 1149.5, 1249.5. Then the requirement for the formula is to multiply f and x. So you need to create another column, which is f multiply with x, right? So this is fx. So fx is, you need to multiply f, this value, and this value for each row. So this one should be 8 multiplied with 749.5. It should be 5,996. This one 11043.5 and 13293, and this one is 10495, and this is 737.5 and 4998, right? And then you need to find the total for this value fx. This one should be equal to 7456 So once you get the value, you just plug in into the formula. This is the value of summation of fx. Right, so 74563 divided by 74. So this one should be equal to 1007.61. So this is how you find mean for group data. Right. Are you clear with this one? So of course we have example number 18 and example number 19. So example number 18 and 19, I want you to do it by yourself. Yeah. Example number 18, I want you to do it by yourself. Same procedure. You need to find the midpoint for 500 and 700, divide by 2. You got the midpoint for each class. And find the value of fx and divide by summation of f. So find group mean. Right. So now, I'm going to leave example number 18 and 19 to you to do it by yourself. Right, now we're going to proceed to another topic, which is median. Right, so median, the symbol for median is x tilde, x with a tilde. Right, so this is a median. So median means that means the middle value of a range data in ascending order. Right, median means the middle value of a range data in ascending order. Right, so the interpretation of median is 50% of the total number of observation having value less than median, while another 50% of the total number of observation having value more than median value. So imagine that we have data from 0 to 100. Right, so the median is the middle value of the data. So this is the median. Right, so 50%, the total of the data is 100%, of course, right? So the total of the data is 100%. So the interpretation of median, 50% of the data, 50% of the data having value less than the median value, while another 50% of the data having value more than the median value. So this is how you interpret the median value lah. Right. So now, computation of median for ungrouped data. We're going to calculate median for group data and ungrouped data. Right. So let's start with the ungrouped data. So to calculate median for ungrouped data, there are 3 steps you need to follow. First step is you need to arrange data in ascending order. So your first step is you need to arrange data in ascending order. And then second step, find the position of median. So the position of median, the formula for position of median is n plus 1 divided by 2. So where n is number of observation lah. And step number 3, locate the median value from the arranged data and determine the median value. Right. So now look at example number 20. So this is ungrouped data, right? So first step, to find median value, you need to arrange data in ascending order. So the first value is 24, 25, 27, and then 38, 40, 45, 48. So how many observations we have? We have basically n equal to 7, right? 1, 2, 3, 4, 5, 6, 7. So first step, we need to arrange data in ascending order. Second step, we need to find the position of median. So position of median. So position of median, the formula is n plus 1 divided by 2. Right, so 7 plus 1 divided by 2 equal to 4. Right, so the third step is you need to locate the median value. So this is the good practice is you need to do a location for each value lah. So this is a location number 1, location number 2, location number 3, location number 4, 5, 6, and 7. So step number 3, you need to locate the median value. So location of median is position number 4. So number 4 is 38. So the median value is 38. Right. So this is how you calculate median for ungrouped data. Now let's look at another example. Right. So don't worry. This video I'm going to put into YouTube. Right. So now example number 21. So this is ungrouped data. So first step is to find median. You need to arrange data in ascending order. So the first value is 101, 105, and then 107, and 111, and then we have 116, 120, 123, and 129. So number of observation we have 8. 1, 2, 3, 4, 5, 6, 7, 8. So now locate the position, the data value. So this is position number 1, 2, 3, 4, 5, 6, 7, and 8. Right. So the next step is you need to find the position of median. Right. So the position of median n plus 1 divided by 2. So this one should be 8 plus 1 divided by 2. 9 divided by 2 equal to 4.5. Right. If you look at the data position of the data, we don't have 4.5, right? To get 4.5 means you need to take the position number 4 plus position number 5 divided by 2. It will become 4.5, right? So then position median value should be, we take the value from position number 4 and value from position number 5 divided by. So this one should be how much? 111 plus 116 should be 227 divided by 2, 113.5. So this is the median value. So how to interpret the median value? Right. 50% of the data having value less than 113.5, and another 50% of the data having value more than 113.5, right? So this is how you interpret median, right? And this is how you calculate median for ungrouped data, right? So now the next topic, how to calculate median for group data. So we're going to learn how to calculate median for group data. Just now is calculating median for ungrouped data. So a bit complex, right? So we have basically 5 steps to follow. So the first step is, if you have a group data, you need to find a cumulative frequency table, right? You need to calculate, you need to construct a cumulative frequency table. And then you need to find the position of median by using this formula, summation of f divided by 2. And after you find the position of median, then you need to determine the median class. And the median class is the cumulative frequency equal or next greater to the position of median. Right. Nanti I tunjuk dekat you how to find the median class. Right. If the group data has no class size, then the median value should be the value satisfied step number 3. If the group data has a class size, then we need to calculate median by using this formula. So this formula means LM means lower class boundary of the median class. Summation of fx divided by 2 is the position of median. Summation of fm minus 1 means the cumulative frequency before the class median, before the median class. And FM is the frequency of the median class, and CM is the class size of the median class. Right. Now, don't worry, I will explain in example. So now look at example number 22. So now, first thing we need to calculate median for group data. This is the group data. Look at whether the group data have a class size or no class size. So in this frequency table, they have no class size. This is your X and this is your F. This is the frequency value. Now, first step is you need to construct a cumulative frequency. So cumulative frequency is capital F, right? Another column named as cumulative frequency. So this one should be 0 plus 12 is equal to 12. 12 plus 14, this one should be equal to 26, 36, and this is 41 and 44. So we know that the summation of F is equal to 44, right? So now, this is the first step. Second step is, we need to calculate the position of median. Right? Second step, position of median class. So the second step is we need to calculate the position of median class by using the formula summation of F divided by 2. So summation of F is equal to 44, right? Because if you total the column number 2, you got 44. This is summation of F. Divided by 2 is equal to 22, right? So second step. For the third step is we need to determine median class. So the median class, in this step, they say that the median class is the class that has a cumulative frequency equal or next greater to the position of median. So the position is median is 22. We need to find the position class where the cumulative frequency equal to 22 or next greater to 22. Do you have equal to 22? Don't have, right? Class number 2. Right. Okay. So this is your median class. So this is median class. Right. So median class is class number 2. So step number 4, if the given group data has no class size, then the median value should be the value satisfied step number 3. So now we don't have a class size, so the median value is equal to 1. Right. So 50% of students taking have number of sick days less than 1. Another 50% have taking number of sick days more than 1. Right. So this is very simple because we don't have a class size. Now look at example number 23. So now in example number 23, by looking at this frequency table, we have a class size, right? So from 30 to 39, 40 to 49, and so on. This is your F and this is your class, right? So first step to find median, we need to create a cumulative frequency table, right? So we need to create another column on the right hand side, right? So this is a cumulative frequency table. So 0 plus 2 is equal to 2 plus 3, 5, 5 plus 10, 11, 15, and this is 29, is it? And this is should be 30, 36, 39, and 40, right? So this is your first step. Second step is position of median class, right? Position of median class by using some formula summation of F divided by 2. Summation of F is equal to 40 divided by 2 equal to 20. Right. So third step is we need to find a median class. To find the median class, the cumulative frequency equal to 20 or next greater to 20. Equal to 20, we don't have 20 in cumulative frequency, cumulative value. The next greater is 29. Right. So this is your median class. Right. So this is median class. Step number 3. Right. So step number 4, right? If your class have no class size, we use that this value. But in this case, we have a class size, right? So 60 to 69. So we need to use the formula. Lower class boundary of the median class plus summation of F divided by 2 minus summation of F m minus 1 divided by frequency of the median class multiply with class size of the median class. Right. Right. So what is the lower class boundary for the median class? 60 plus 59 divided by 2. It should be 59.5. Right. Are you okay with this one? Right. So position of median, summation of F divided by 2, it should be equal to 20. So plus 20 minus summation of F m minus 1 means the cumulative frequency before the median class. This one, 15. Right? Cumulative frequency before the median class is equal to 15 divided by frequency of the median class, 14. And multiply with the class size of the median class. What is the class size? It should be equal to 10. Right. So the median should be equal to 63.07. So this is the median value for this data. Right. So how to interpret? So 50% of 40 students having marks less than the median value, 63.07, while another 50% of 40 students having marks more than 63.07. Right? Very simple. Right? So this is on example number 23. So example number 23 I have done. So I leave to you example number 24 for you to do it by yourself. Right. So
Sir.
yeah.
Sir, can you repeat? For example, jalan kerja.
Yes.
Yang tadi yang tab 4. Formula.
Why we have median, this value, right?
Yes.
So first we look at the frequency table, right? So in our frequency table we have a class size, right? So if we have a class size, then we need to use this formula to find median, right? So the formula is lower class boundary of the median class plus summation of F divided by 2, which is your position of median, minus summation of F m minus 1 means the cumulative frequency before the median class, divided by Fm means the frequency of the median class, multiply with CM means the class size of the median class. So lower class boundary of the median class, right, is this one lah, right? The lower value can. But this is not a class boundary, this is a class limit. You need to find a class boundary. 60 plus 59 divided by 2, which is equal to 59.5. And summation of F divided by 2 is position of median, which is equal to 40 divided by 2 equal to 20, right? So this is the position of median, right? And then minus with summation of Fm minus 1. Summation of Fm minus 1 is the cumulative frequency before the median class. This is a median class. The cumulative frequency for median class is 29. Before the median class is 15. So that's why summation of Fm minus 1 is 15. And divide by Fm. Fm means the frequency of the median class. So frequency of the median class is equal to 14. So that's why 14. And multiply with Cm. Cm is the class size of the median class. So class size from 60 to 69 is 10, right? So you just input the value into the formula and you will get the value of median, 63.07. And how to interpret? So 50% of the 40 students having marks less than 63.07, while another 50% having marks more than the median value, 63.07. Are you clear with that? Are you okay?
Okay, sir. Okay.
Right.
Thank you, sir.
So now, look at the next topic. But for this one, I already show you, for example, number 24, in the last class, I already show you how to get median value from less than or give, right? So I leave it to you, example 24, for you to do it by yourself and post it into Flipgrid, right? So how to calculate median for this frequency table and find the median from a less than or give, right? So the last topic for measure of central tendency is mode. So the symbol for mode is X with hat, right? Mode means the frequent value occur in the most frequent value to occur. This is what we call as mode. Mode can be, the value of mode can be more than 1, right? So they can be 1, 2, 3 or more, right? So now we're going to calculate mode for group data and ungrouped data as well. All right. So now look at computation mode for ungrouped data. So find example number 25, find a model value for a given data. So now we look at 17, 14, 16, 20, 18, and we have 12. So 17, how many observation? Kita ada satu saja kan? 14, we have 4. 1, 2, 3, 4. Ada 4 value. And 16, we only have 1. 20, we only have 1. 18, also 1. And 12, also 1. So the mode value is equal to 14. So we have the most frequent value to occur. This is the mode, right? This is how you calculate mode for ungrouped data. Now look at example number 26, right? So we have 800, 700, 600, 800, 500, 6, and so on. So 800, we have how many observations? 1, 2, 3. We have 3 observations. 700, we have 1, 2. And 600, we have 2, 1, 2, 3, right? And last one is 500. We have only one. So now, by looking at the most frequent value to occur, we have 800 and 600 have 3 observations. So mode for this example, we have 2 modes. Mode number 1 and mode number 2. Mode number 1 is 800 and mode number 2 is 600. Right. If you draw a histogram for this data, let's say 800, you akan nampak 500. Let's say we start with 500 only, 1, right? 700. So let's start with the 800 first. Right, 800 we have 3, let's say 3 over here, and 700 should be equal to 2, and 600 3, and then 500 equal to 1. So you're going to see there are 2 modes. Right. So this is how you calculate for ungrouped data. Right. Now, example number 27. So by looking at example number 27, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observation. So 20 we have 1, 2, 3, 4, 5, and 40 also have 5. So there are no mode here because there are no most frequent observation occur. So both are same, 5 and 5. For example number 37, we don't have mode. Now, just now is calculation for mode for ungrouped data. So this one is calculation mode for group data. So for group data, the mode will refer to the highest frequency of a frequency table. So now look at this one. We have basically 3 steps to follow. Right. First step is we need to find a model class, that is the class that has a highest frequency. Right. If the class have no class size, then the model value will be the value of the variable that has a highest frequency. If the group data have a class size, then we need to employ this formula. So the formula is x hat, which is the symbol for mode, equal to lower class boundary of the model class plus theta 1. Theta 1 means frequency of the model class minus frequency before the model class. This is theta 1. Divide by theta 1, which is equal to above, plus theta 2 is equal to frequency of the model class minus frequency after the model class, multiply with class size of the model class. So this is the formula for group data, right? So now look at example number 28, right? For example number 28, we have a group data because it's present into a frequency table, right? So this is your frequency and this is your X. Look at the class. We don't have class size for each class, right? Because the value is 1, 2, 3, 4, 5, 6. So the mode for this class, for this table is, you need to find the model class. Model class is the highest frequency value. The class that have highest frequency value, which is 12. Right. So 12 is the most, it is the highest value of the frequency compared to others. So now, since we don't have a class size, the mode going to be 2. The mode is this value. This is the mode. Right. Very easy. Right. So now look at example number 29. So example number 29, now we have a class size 30 to 39, 40 to 49, and so on. So to find mode, first step is we need to find the model class. The model class is the class that has highest frequency. So the highest frequency is 13. So this is your model class. right? This is your model class. So since your data have a class size, so we need to employ this formula. Lower class boundary of the model class plus theta 1 divided by theta 1 plus theta 2 multiply with class size of the model class. Now, lower class boundary of the model class is 60 plus 659 divided by 2, because this is not a class boundary, right? This is a class limit. So you need to find a class boundary. So the class boundary is 60 plus 59 divided by 2 should be equal to 59.5, right? And theta 1 means frequency of the model class minus frequency before the model class. This is frequency model class. This is frequency before the model class. This is the frequency after the model class, right? So this one should be 13 minus 10, right? So theta 1 is 13 minus 10 plus theta 2 means frequency of the model class minus frequency of after the model class. So 13 minus 8. Multiply with the class size is equal to 10. Right. So this one should be equal to how much? This one should be equal to 63.25. Right. So the mode of marks for 40 students is 63.25. So most of the students have 63.25 marks in their exam. Okay, right. So now look at example number 30. So example number 30 are also same, right? So now, before we go to example number 30, now look at example number 29. If I want you to draw a histogram from this data, right? Let's say we have, this is 2, this is 4, let's say letak kat sini 4, this is 10, this is 13 more, and this is 8, this is 2 again, and 1. So we will get more likely like this lah. This is starting from the 29.5 and then 39.5 until 99.5, right? So this one should be 59.5 and 69.5, right? This is histogram. To find mode from histogram, right? If you look at the histogram, you can see only one bar have the highest frequency, right? So we only have one mode, right? To find mode from histogram, you need to join this value, data value to this point and this point to this point, right? So this intersection is your mode. So this is how you find mode from histogram. So that's why I require you to draw a proper histogram with a proper measurement scale, right? Okay. So now look at example number 30. So in example number 30, before we start, so let's draw a rough histogram. Let's say this is 15, and this is 14, and this is 18 atas sikit, right? And this is 8 somewhere here, and this is 18, and this is 2. So from the histogram, we can see that we have two mode, right? This is mode number 1, and this is mode number 2. We have two highest bar, right? Okay. So for this calculation, this data, we should expect to calculate two modes lah, because we have the highest frequency is 18. We have number 1, and the second one is 18, right? So are you okay? Are you clear? Are you clear?
Yeah,
Right?
clear.
Yes, sir. Yes, sir.
I'm very clear.
So this is going to be mode number 1, and this one to be mode number 2. So since we have a class size, so we need to calculate mode number 1 by using the formula. So lower class boundary of the model class, let's put this one, lower class boundary plus theta 1 divided by theta 1 plus theta 2 and multiply with class size, right? So for mode number 1, the lower class boundary is 22 plus theta 1, 18 plus minus 14 is equal to 4. 4 plus 18 minus 8 equal to 10. And multiply with the class size, this is going to be 2. So this is calculation for mode
Still
number.
tak clear. Still tak clear.
Clear? Can you listen? Can you hear me?
Clear, sir. Clear.
Okay.
Right. To calculate
Okay.
to calculate the first mode, right? This is a first mode. This is a first model class. The lower class boundary is 22 because we have a class. This is a class boundary, right? 22 plus the theta 1 is the model class frequency of from model class minus frequency before the model class, 18 minus 14, which is equal to 4. And theta 2 is 18 minus 8, which is equal to 10. And multiply with the class size, 24 minus 22 equal to 2. That one is for mode number 1. For mode number 2, the lower class boundary is 26 plus frequency for the model class, for this model class, minus frequency before the model class, which is equal to 10. 18 minus 8 equal to 10. This is 10 plus 18 minus 2, frequency of the model class minus frequency after the model class. So this one should be equal to 16 and multiply with 2. So this one should be equal to 22.57, and this one going to be 26.77, right? So this is how to find mode, right, for group data. Okay, so now example number 31, the last example for mode before we end our lecture today, right? Right. This is group data. So before we start to calculate mode and to know how many modes we have, we need to draw a rough histogram, right? So let's say this is a 15, this is 14 and 18. This one, the fourth one is also 18, and this is 8, and this is 2. So by looking at this histogram, how many modes can you guess? By looking at this one, we only have one mode because you can see the bar is stick together, right? The highest bar is stick together. So this is, in this example, we only have one mode. So the model class for this example is this one, combination of two class, right? So now to calculate the mode, right? So the lower class boundary is 22 plus frequency of the model class minus frequency before the model class, which is equal to 18 minus 14 equal to 4, divided by 4 plus frequency of the model class minus frequency after the model class, 18 minus 8, which is equal to 10. And the class size is 22 until 26. This is equal to 4. Right. So this one should be equal to 23.14. So this is the model class if you have the highest frequency are stick together side by side. Right. So for the above table, estimate the model class using histogram. Same as before. This is the histogram. You need to draw histogram in proper measurement scale, right? So you need to connect these 2 points, right? And these 2 points. So the intersection between the line is your mode, right? Okay. Right. So if you look at the manual, right, the workbook, so we have a characteristic of mean, median, and mode, right? So this one you should read by yourself, right? Now I just want to explain the relationship between mean, median, and mode, right? So if you have mode more than median, more than mean, right? So we can say that the data is skewed to the left, right? So the skewed to the left data is look like this, right? This is from negative infinity to infinity. This is your mode, right? This is your median, and this is your mean, right? So if the mode is the largest value, larger than median, and median also larger than mean, so we have a skew to the left distribution, right? If otherwise, if you have, this is from negative infinity to infinity, if you have mode smaller than, this is mode smaller than median, smaller than mean, right? So median is the highest, mean is the highest, higher than median, and median also higher than mode. So this is Q to the right distribution, right? This is skewed to the right distribution, right? So, in other hand, if you have the same value, mode is equal to mean, right? This is from negative infinity to infinity. Mode is equal to mean, right? And equal to median. So then we can say that the distribution is symmetrical, right? Or normal distribution. That's all. Right. This is the first part for a measure of central tendency, right? Are you okay? Class, are you okay?
Okay.
Okay.
All right.
Okay, sir. Okay.
So this is the first part of chapter number 3. We will continue our lecture on next Monday for